Hello pre-calculus students, we are starting Unit 8 today, and this is a unit on exponents and logarithms. So our warm-up is a review of what you learned on exponents and logarithms in Algebra 2. So in the first problem we are simplifying an exponential expression. Remember that you have some exponent rules. When you multiply, you can add the exponents. So I'm going to add I have x to the 5th times x to the 1. That would give me x to the 6th. And let's see, nothing else is going to combine on top there. Another exponent rule is that if you have a negative exponent, you can move that to the other part of the fraction and it can become a positive exponent. So I'll take care of that as well. So I still have z to the 1/2 on top. And I'm going to move the y to the -2. I'm going to move that to the denominator and it becomes y squared. I have an x squared down there. And I had a z to the -1/2. I'll move that to the top and it'll become z to the 1/2. And of course, this is all in parentheses and a third power out here. So then once again, I have z to the 1/2 times z to the 1/2. I'll add those and get z to the 1 on top. And then another exponent rule says when you divide powers of the same base, you can subtract the exponents. So 6 minus 2 will give me x to the 4th. So I have x to the 4th, z to the 1 over y squared. And that's all to the 3rd power. And then the last exponent rule we're going to use here is when you do a power to a power, you multiply your exponents. So 4 times 3 will give me 12. So I have x to the 12th, z to the 3rd, and then 2 times 3 gives me y to the 6th in my denominator. Okay, when you write as a radical, remember that the numbers are power over root. Power over root. But I want to write these as a single root. I don't want to have a square root and a 5th root, so I'm going to find a common denominator with my two fractions. So my common denominator would be 10, and to make this denominator 10, I need to multiply by 5 over 5. So I have a to the 35 over 10. b, I'll need to multiply this fraction by 2 over 2, so that would be 8 over 10. And then I can make this a 10th root. So 10th root, a to the 35, b to the 8. And then anytime I have 10 a's, that can come out. So the 10th root, just think of this, the 10th root of a to the 10, the exponent and the root would cancel, giving you just a to the 1. So what I can do is I can take 3 10s out of this. That would give me a to the 3rd. It's still a 10th root. That didn't go away. If I take 3 10s out, I'm still left with 5 a's. So I have a to the 5th. And I don't have enough b's to take any b's out because I would need 10, and I only have 8. So that's b to the 8. Okay, so when you're rewriting as a logarithm, it's helpful to keep the rule handy. If you have a base to the x is equal to some y, you can change that so that you have a log, and the base of the exponential is the base of your log, so log base b of y is equal to the exponent. So remember that the answer to a logarithm is the exponent. All right. So I'm going to write the word log. The base of my log is 5. Next comes the 125, and the answer to the logarithm is the exponent. Okay, to evaluate a logarithm, you want to rewrite it so it looks like an equation. So you can just write equals x after it. And then the base of your log is 2. The answer is the exponent, and this equals 32. So I need to answer the question 2 to the what is 32. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so 2 to the 5th. So x is equal to 5. Okay, I'm going to do the same thing here. I have equals x, and I get base 25, exponent is the answer, equals 1 over 125. So 25 times 25 is 625. That's too big. I need to do something else here. So I'm going to change these both to a base 5. So 25 is 5 to the second. (125) is 5 to the third, but this is the reciprocal, so it's going to be 5 to the negative 3. When you have a power to a power, you multiply exponents, so I get 5 to the 2x is equal to 5 to the negative 3. Now the bases are the same, and I want these two things to be equal, so the exponents are going to have to be the same. So now I can just write 2x equals negative 3. Oops. And x is going to equal the fraction negative 3 over 2. In number 6, we're trying to find the domain. Remember that the input for the logarithm has to be greater than 0. So you just take that input, x plus 4, and you set it greater than 0. And you get x is greater than negative 4, which in interval notation would be from negative 4 to infinity. Okay, so that's the end of the warm-up, and you'll find a new video for your notes.